world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also at the end of today's webinar, we are going to be doing a drawing for 6 Amazon gift cards worth $25 each. So please stick around, hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar. I'm really excited about this one. What going all remote taught us about Appsec and testing shortfalls. Our speakers today are Gleb Bamatov. I think I got it right, maybe? Yes, okay, right. All right, great. So he's the VP of Engineering at Cypress, and Reese Arkins, who is the Director of Product at WhiteSource. Gentlemen, thank you so much for joining me today. Really appreciate it.
Thanks very much, Charlene.
All right. So Reese, I know that you're going to be kicking off the conversation, so I'm going to take myself off camera, put myself on mute, and let you guys get right into your conversation.
All right, thanks a lot. All right, so today's discussion is around what going all remote taught us as an industry, and we'll talk about what were the obvious changes, many of which are perhaps temporary, but then focus on a few of the non-obvious things that these kind of changes exposed in our workflows. And naturally, we'll speculate on what that all means in the future, especially with respect to Appsec and testing as our focus. So the obvious big change was working from home. And as I heard it described, at home, during a pandemic, trying to get work done, right? But like if we look at the working from home theory, we'll call it, I mean, it's pretty good in theory, right?
Yeah.
Uninterrupted, you know, there's no colleagues tapping you on the shoulder. Hopefully even like increased availability due to no commuting, you know, like no one's getting stuck in traffic, has to sort of leave early. And then, you know, in theory, again, like relaxed and happy. I mean, this is the theory of working from home. And so, you know, with the COVID-19, we sort of refer to as working from home, but that's perhaps not the true meaning of the word. Now, something to point out quickly is that working from home is not actually a change for myself or for Gleb. Gleb, you've been the VP of Engineering at Cypress for around 3 years now, and you've worked remotely for most of that, right?
Yes, I work completely remotely. Cypress is remote first company, but about half of our employees work from the office. But now for the last 2 months, they had to work from home too.
Right, so that's interesting. So that's like a remote first company, but you have still had those changes from having a bunch of the team that are used to working side by side, you know, now also being remote. Right, so then, you know, with our overnight all remote teams, we've got no more commutes, you know, no more office chairs, coffee machines, face-to-face meetings. Those are the things we lost. What increased? Apart from our respect for our children's teachers, that is. So actually what increased a lot was interruptions, right? So yeah, so
Zoom meetings increased a lot.
Zoom meetings, exactly. Zoom meetings, hand sanitizer. So Zoom and other conferencing tools certainly picked up a lot of the slack from the face-to-face time,
Yeah.
right? The face-to-face meetings, but they certainly didn't pick up all of it. Working from home during a pandemic, it isn't the same as planned full-time, you know, remote work from home. So even those of us who have been quite used to work from home had far less control over our schedules and over our environments. We also saw a lot of increase in asynchronous communication. All right, so Gleb, asynchronous is a tech term. We typically have a tech audience on DevOps.com, but I'd like for you to describe in simple terms as possible, what do you think of when we say asynchronous communication?
So when we say about asynchronous communication, it kind of goes hand in hand with remote. But it means that you're not interrupting someone, you're not asking them for an answer immediately. And it's very important for remote work because in the office, I can see like, Chris, you're busy, you're in the flow, you have your headphones on, so I will not interrupt you. But when you're asking someone remotely, by email, by video call, you probably interrupted them. So that means, asynchronous means you're not communicating directly. You're asking for an answer at some point later when it's convenient for another person.
Okay, so it's acceptable to answer later rather than have to answer right away. All right, yeah. So no more face-to-face. So here's where we kind of come to the focus of the discussion. For some companies, the shift to asynchronous communication methods also expose weaknesses in how we test, how we secure our software. All right, so one of the key topics we're talking about here is that software maturity is partly a factor of process and automation. So Gleb, even before the pandemic, what do you think are the major differences between how like co-located teams, if we use that term, like people side by side, what's the major differences between co-located teams, how they communicate versus how distributed teams communicate?
I would say that the team that's not in the same office, that's not using verbal communication a lot, those remote teams, they have to rely a lot more on written documentation and on automation, right? Because you can't assume, oh, I'll just ask a question if I don't know something, right? Because asking the question with asynchronous communication might take some time. So you better have things written down and even better automated.
Right. I've seen the like GitLab, for example, is a fully remote company, and they write down an amazing amount of things, and they've just done that as part of their learning how to have fully remote teams. So in a way, the stakes you'd say are different when you're remote, or the risk is different. Like if you lose concentration, when you're like riding on a bus, it doesn't really matter. But if you lose concentration when you're driving a race car, you might crash out of a race, right? So these stakes are a little bit different when you are communicating remotely.
Absolutely, because you lose a little bit of that human communication of like non-verbal clues where you say, is this something I have to worry about? If it's not written down somewhere, that means you probably don't remember about it. So it can just slip your mind. So the stakes are higher. When you're collocated, you have a buffer where actual communication, being in the same room, can pick up a little bit of slack. But once you're remote, you better have those processes written down so you don't forget about them.
Right. So I think that co-located teams can have very good process. Naturally, they can have better process. No problem at all. I think the bit of the difference is that they do have this buffer that you mentioned, where if things get forgotten or missed, then they have kind of like ability to catch up on that. So I know for sure that you are a fan of automation. In fact, the reason why you and I ever first chatted, which was years ago now, was because of one of your open source tools. I love automation myself. Building an automation tool was how I came to join White Source. So here's how I think about it. If like what you don't automate, you are going to one day forget. Basically, that's how I put it. So for things that you can't afford to forget, you have to automate. What do you think?
That's the reason I joined a company that writes software that you can write to automate all your testing tasks. So I agree with you.
Cool. All right, so then let's talk automation, starting with security. We'll talk a bit about open source and dependencies, and then finally about security. That's one of the things that I
Risk, can you repeat the last
focus on
sentence?
these days.
Cutting out.
So straight up, I'd say, I think that as a software industry, as a security professional, a security insider in the software area,
Oh, Risk is cutting out a little bit for me.
Hey, Reese, can you hear me?
Yeah, I can hear you, Charlene. Sorry, do you hear me?
Okay. Yes, your video and your audio have both kind of
Yeah, I
cut
dropped
out.
the video
So
when I got a message about the connection. Let me try again. So we're
okay.
talking about automation, starting with security. And I was posing a question to Gleb. I was saying that I feel as someone who is sort of on the inside in the security area and software building area that we have a lot of maturing to do with security and testing. And I wondered, Gleb, do you also sometimes worry about how good we are at these types of things?
Oh, thank you, Reese, for repeating the question. Absolutely. When you go to a website by a billion-dollar company and then you see that like the drop-down doesn't work, what it means to me is that they have not tested even that simplest like user interface thing. That means probably that they forgot to test real important stuff like security or maybe upgrades. So I'm really worried that if you see something that's obviously broken, but there are many things under that layer that haven't been tested as well. So I'm really scared sometimes.
Right. There's like a story about an old rock and roll band that used to have a requirement that if the organizers didn't get rid of all brown M&Ms, that they would be fined. And that wasn't because they hated brown M&Ms. It was because it was a sign that people weren't reading, the instructions clearly. So I think what you talk about there, where little things break in websites, is potentially a sign that bigger, more important things are breaking. I do, though, concede security is pretty hard. Like, you can't just say the word security, snap your fingers, and it's done. It's pretty much like a never-ending challenge.
Absolutely. But there are things you can automate, and the things you automate give you more time to concentrate on the things that are hard to automate. And I think security is a little bit hard to automate.
Okay, so Gleb, you created this slide. I think it's pretty important for understanding like the significance of open source use in companies today.
Yes. So in my opinion, the code that you write yourself, it's only like this thin layer of ice that you see above the water. The real thing, like the 90% of the code that your users get when you ship your product, are actually the stuff you don't write. And I'm usually talking about open source software. It's written by people you don't know, you don't control, you don't pay them, but it directly affects your users. So you have to remember that.
Okay, so we're going to dive into the challenges of, no pun intended, we're going to dive into the challenges of securing open source under the water. But let's first talk briefly about application security for the code that you do write, above the water here. So once we've done that, we'll talk about the code you don't write. So starting with our own code, the industry term for this type of testing is application security testing, AST. So SAST stands for static and DAST stands for dynamic. Now, DAST is like black box testing. So, that's essentially performing it from an outsider's perspective, maybe like pen testing type of approach, while SAST is essentially source code inspection. So because we're talking about inspecting our own code here, SAST will be the focus. So my quick take on today's SAST is that it's generally perceived to be too slow to be used all the time. So like if you run on every commit, let alone keystroke or something like that, or every save, you're going to have a real time trade-off. You're unlikely to be able to run it locally as some type of continuous process. It really means, if it's too slow, it really means that it's not yet well suited to continuous automation.
I think you're right, and I think many companies are looking into ways to speed this process. And for example, like GitHub, which is like the biggest place for open source, that's why they acquire companies that try to do machine learning to analyze the source code faster. So I'm really looking forward to what we can accomplish.
Like we lost Reese again for a second.
Right.
Reese, are you with us?
Where you see it going.
Okay. Hey, Reese.
I am with you. I apologize.
Okay.
So,
No.
Gleb, if you hear me,
Yes.
I'm curious. Yeah.
Yeah.
All right. How would you characterize application security risk in our software today? Are most companies betting lots of mistakes? Are they unaware of it? Can we improve it?
Well, there is a difference between being aware and doing something about it. And we all know, for example, that buffer overflow is a common mistake that leads to security exploits. And so people are now starting to take drastic measures. For example, going from C and C++ to Rust, or going from JavaScript and Node.js to Deno. What will really mean in the long term remains to be seen, but you have to sometimes take a big step for security. Reese, are you with us?
Well,
I think
I guess for Reese. Oh.
Maybe I can go over the slides while Reese is reconnecting. So we talked about.
I dare say, do you hear me now? I apologize.
We do hear you now.
Okay, Gleb, so which slide are we up to?
Application security for the code, others, right, the 90%.
Okay, all right. So thank you very much. So the code, let's say for an angle you don't write, so open source dependencies, essentially.
Yes.
Well, unfortunately, I'm asking you again. What's your take on this? Particularly, what do you think is why do you think an automated approach is important for open source security instead of, say, manual or ad hoc approach?
Well, there are two factors, in my opinion, that make security in the dependencies that you bring from open source very important. One is that it's public. So once a security exploit is published for open source library, every hacker knows about it, right? That means if you have this code running in production, it could be attacked immediately, right? And the second factor is that this is the code that written by people you don't control, right? That will probably not go and patch, previous versions, right? So you have to stay up to date if you want to receive a patch. And another thing that is just a sheer amount, right? We talk, it's the iceberg of a code that you write versus so many dependencies, right, below, that you just have more security exploits, more updates to deal with. So you probably want to automate the dependency updates for the code you don't write.
Okay, so this is clearly a category of application security that you shouldn't make, ad hoc, manual. We don't want to rely on people just remembering or reminding you, perhaps, if you forget. There might even
Well, yes, you can assume that someone will get to it once in a while, right? You can't just say, well, once a month, someone will take a look at that. Ideal situation is that the dependency updates for dependencies that you use will be done and tested automatically and on schedule, so they don't fall behind for a long, long time.
Okay. All right. So as you know, I have a lot of opinions on open source dependencies myself. I know you've been an early adopter of dependency automation in particular, both personally as well as at Cypress. So today I'd like to hear what you've learned and also like how do you reduce your application security risk through automated dependency management?
Right. So one thing that brought dependency updates into my attention is that even for small web applications, and I work with applications on the web. So that's why my examples are web apps. They might have just a small number of direct dependencies, right? Maybe 5, 10 production dependencies, 5 to 10 dev dependencies. But when you look at those dependencies and dependencies they depend on, it's actually a giant tree. So even a small application might depend on 100 to 1,000 transient dependencies. And guess what? If something goes wrong, if there is a security exploit, right, that affects my users, I will be blamed for any problem, right? Just like, the captain of Titanic will be blamed. So for me, the question is not if there is a security exploit that I have to upgrade, right? But when. And when like a pull request is open saying, hey, you have the security issue in this version of a library, you have to upgrade as soon as possible. Are you going to be ready? So Lewis Carroll in Alice in Wonderland said, my dear, here we must run as fast as we can just to stay in place. And if we wish to go anywhere, we must run twice as fast as that, which doesn't make much sense, but I think it makes sense if you think about like amount of dependencies that we have to consider when we upgrade. So back in the day, if you have a dependency upgrade, you can kind of talk to people, say, does this write to you? Should we care about this? What do you think? But I think this is gone. So now we probably want to automate it. I don't think automation by itself solves the problem. If you enable dependency upgrades for all your dependencies, then you'll get like constant flood of dependencies and notifications. So I had a long battle with that flood. I use pretty much every commercial dependency upgrade service. I've written my own next update. So it's not about particular tool, but it's about the process. So lots of dependency updates, but just thrown at you can be overwhelming. So what do I want from dependency updates? I want them to be meaningful, configurable, and automatic. So meaningful means that for every dependency update, I want to know, is this a new feature or a bug fix or security fix? Like, why should I care about this particular update? I want it to configurable, right? I don't want to have a flood of 100 pull requests every day across my project saying, upgrade this, upgrade that, because not everything matters in the same degree. And finally, for each dependency upgrade, I really want to do as much manual review and work as possible, right? Otherwise, I'll just be working on dependency upgrades all day long. So one rule for me is you have to prioritize. You want to label your most important dependency. That means you have to look at your software and say, this is important, but the rest is less important. So in my opinion, the priority is on your web framework, maybe your backend framework, maybe your main production libraries. You want to prioritize dependency updates for those things first, right? And have dependencies often. And this will benefit your users directly. First of all, you will never fall behind, so that if security patch is issued, you can upgrade because you are way behind. Also, each major library, each major framework probably is getting performance improvements, bug fixes all the time. So by upgrading often, your users will actually benefit. It will become faster, it will become more reliable. Things that are less important are your build tools, maybe some minor production utilities, right? You can still upgrade them, but it doesn't have to be immediate. It doesn't affect your users because like the build tools code is not running in production. So what I usually do is that I rate limit all my dependency upgrades, right? And I concentrate on things that are production dependencies. So even if there is a long list, I can pick and I say, well, those two probably should be reviewed and merged first because these are in production. So in Renovate, which I settled on because it solves all my problems very, very well, you can configure a lot of options. So one thing that I do across all my projects, I set up upgrades for most important production libraries, because these are the libraries included with my web application code, and my users care about those libraries because they're running that code. And both libraries and the finished web application will have automatic tests. So if a test passes, I feel pretty confident that I can upgrade. So one thing that we do at Cypress and for my personal projects, when automated system opens a pull request saying, I want to upgrade, we usually have a checklist. So again, remember, in our asynchronous communication, we don't just remember those things, we write them down. So every time there is a pull request open, we have a bot that posts a guide or a checklist for specifically dependency reviews, where we say how to evaluate, how to look at the change log, what to do. The biggest pet peeve of mine is that not every dependency is using semantic release or semantic commit convention. That means we have to look at the change log in detail to understand what that upgrade means. Really quick, semantic release means that every commit that you make into your software follows a certain convention. For example, you start the commit message with a patch. That means that you're fixing a bug. If you start your commit message with minor, that means you added a feature. And if you add your start your commit message with major, that means you're not fixing a bug, you're not adding a feature, but you're refactoring something in a way that breaks existing API. So upgrading will be harder. And then every version, right, has major, minor, patch numbers. If you follow that, then you can automatically generate a meaningful change log. So this is an example of a change log. So anytime you see a new version, like 5.0, that means there is a breaking API change in this dependency. So upgrading it has to be a careful process, because it might require, effort. Maybe something has changed. You can't just blindly upgrade to this version and expect it to work. Maybe, but probably not. Every time I see an upgrade to, let's say, from 5.0.0 to 5.1.0, it's a minor upgrade. That means a new feature has been added, but all existing features should be working the same. So I'm a big fan of semantic versioning and meaningful change logs.
Hey, Cliff. So thanks for that. The takeaway I have from that is that when it comes to open source security, you really got no option but being able to move fast. So like, you can't choose to just sit still on vulnerabilities, because the guy who's trying to attack you, he gets to decide as well, right? So
yes.
The challenge is moving fast, though, has its own risks. Like, Facebook was famous for coining the phrase move fast and break things. But let's now talk about how to minimize the chances of breaking things while moving fast for security.
I hear this question all the time, and it's very common to say, like, or ask, why do I have to upgrade if my old version is working fine, right? But if you're staying on an old version, right, you accumulating bugs all the way that are discovered, and you're accumulating security issues that are discovered, with each version. And at some point, you get so far behind when there is a real problem, and you don't have a repetitive process that you exercise many, many times, you won't be able to do it. And you won't be able to do it quickly. And it will be a painful process. And in between, your users will be exposed to security exploit, right? So it's not a question of if that happens, it's when this happens.
Right, so the risk isn't so much that, like, the fixing of the vulnerability breaks something, because ideally they are small, and they just patch the minimum code. The risk comes from all of the feature releases in between that you've just been, like, skipping or ignoring.
Yes, and even if you don't have good tests, right, it's not even the new features that were added. Even a simple bug fix that has been backport, it might introduce its own bugs and breaking features, right? So you never know about good tests.
Right. So this is where we need to introduce another important point about automation for application security. And I think it's often very much underappreciated, because to move fast with application security, you need great automated tests. Because without automated tests, you're either at risk of being, unaware that you broke something on your website, the drop downs and so on, or you're kind of back to square one, where you just, you have to hope that, the human testers won't miss anything, and you hope your human testers aren't sick, aren't distracted, and things like that.
Oh yeah. Without great, things, without great tests, like all these things are just, our talk, right? You can't have great security without good automated tests, in my opinion.
Right. So most developers, they are familiar with unit testing, the terms like code coverage, but really that focuses on your own code, and in fact, it's normally good practice to like mock external libraries. So therefore, like typical unit testing and code coverage may not be actually great at catching faults in the open source libraries you use. They deliberately targeted what's above the water, not below the water. So we need to do more than just that, though, to be confident to, patch open source, updates and vulnerabilities and so on.
Right, and I'll talk about code coverage a little bit later, but I do believe that it's not just unit tests. I think you want to exercise your whole system to be confident. So you need automated integration or end-to-end tests to be safe.
Right. So, okay, so we've got about like 10 more minutes before we want to start taking audience questions. Can you tell us about how automated integration testing works, end-to-end testing, particularly when it comes to websites? Because application security is most important for public-facing software, and for most companies, there's really nothing more public than their own website. So let's see what you got for that.
Excellent. So one thing that I always do, I separate, production dependencies from dev dependencies. And in between, there's usually overlap, the dependencies that I trust, right? But I still have to test it, but they probably, require less risk. Again, we cannot, do this. We can't just stay next to someone and just say, does this look right to you? What's your gut feeling? No, it has to be automated. So how do we ensure that we do as little manual work as possible for each upgrade? So imagine you have a pull request open that tries to upgrade some library. Like, do you trust your test enough to auto-merge, right? That's would be the ultimate goal, is that a dependency upgrade comes in, says, there's a new version, all the tests pass, it's green. Now, what do you do next? Do you trust it to automatically merge it? So one thing that I would suggest, and like I always use, is don't upgrade to a new major version, right? Major version means there is a lot of refactoring. It might actually accidentally break something else. So we usually wait for a patch version after that. So we don't upgrade from 5 to 6.0.0. We usually wait for 6.0.1 or 6.1.0. But another thing is that, do you trust your test to find all possible errors and mistakes in the code, right? And mistakes can come from so many different areas, from the syntax and types to algorithms, to security, performance, and like deployment errors. So if you have a linter that statically looks at the types and the code syntax, you can completely eliminate those sources of error. So I suggest always running linters. You have to cover your code in meaningful tests that actually go through all the algorithm paths, so you can find errors in your algorithm, your logical errors. So in this case, I want to talk about Cypress for a second, right? So it's open source, free software that we work on that tests anything that runs in the browser. You install it with a single command. You write a test that looks like this, that opens a website, make sure that like free to do elements are shown. You use real browser to run the test, and a realistic test will actually look a lot like this, where it's like a user that opens a website, maybe adds a couple of to-dos, maybe checks what it can complete a to-do, and then remove one. It's a realistic test, a realistic end-to-end test, but actually runs your website, right? Like I said, I have more confidence that this kind of test will find all possible errors. So when you talk about finding all possible errors in your code, you probably want to cover your code in tests. And how do you know that you're covering your application with tests? Well, you can do it manually, right? You can kind of collect all the user stories and write tests and kind of write matching tests. And every time you update a feature or a test, you kind of have to keep those two in sync. And I think this is extremely hard. Again, it's a manual process. It probably will work for a while and then it will stop. And because it's not automatic, it will be hard for you to use it reliably. So instead, we recommend using code coverage. So how does code coverage work? Imagine you start from scratch. You implement first feature. You probably have written some code. You implement second feature. Again, you've written some code. You implement third feature. Again, it adds more code. And imagine you can instrument your code. So when you run your end-to-end tests, you get those green markers that say those code lines were executed while the test ran. And the red markers mean those particular code lines were never executed. So you look at those red lines and you try to play a detective, trying to see what feature did I not test. And then you write a test for that feature. And then you run the test again. And if everything is green, then you know that your tests match the source code and they cover it. Now, it's not a direct measure. You still don't know if all the features correspond. You're just measuring the code that implements the features. And people really try to get to 100% code coverage, but it doesn't mean you have no or zero bugs. Your code that you cover might still implement the feature incorrectly. And also your test might be unrealistic and just exercise some data, but not all the edge cases. But it still is better than nothing. We at Cypress have written a plugin to collect code coverage from instrumented websites, and it does pretty much everything for you. But one thing why I like end-to-end tests for websites is that they're extremely effective at covering a lot of application code because they load the full website. So even a single test that just opens a website, adds a couple of to-dos, and then checks that there are really free items. When it runs like this, it looks very simple, just a single test. But if you look at code coverage, you're getting a lot of bang for your time investment. A single test like that can cover like 73% in this case, because you're really loading the full web application, you're interacting with it. So you pretty much exercise a lot of code. So then you look at the code paths that were not covered, write more tests, and it's easy to achieve very high code coverage because you cover a lot with end-to-end tests and maybe a few missing things with unit tests. But it's not the end of the story. The functional tests are good, but what about CSS and styles and SVGs? So for those, you want to write visual tests. Visual tests work almost like end-to-end tests, but at some points you want to say, just take a screenshot of a whole page or its component and compare it with a baseline. And then this software looks pixel by pixel and can find differences in color. So for example, if you change the color from red to black, you will see the difference. So those kind of tests find all the mismatches in layout, in fonts, and CSS. So they're a good complement to functional end-to-end tests. If you have accessibility checks, I strongly encourage you to add accessibility tests so that if, for example, this test fails, it will tell you, the contrast or ARIA label is missing, and all things like this are easy to automate. So I've shown these examples, but I think end-to-end tests can also find errors in your compiling toolchain and bundling, your deployment variables, your database setups, because these are true exercises of your website or web application. And then there could be other tools that are not I would say, as easily automated for finding security issues and performance issues. But majority of cases, you need end-to-end tests to be reliable. So if I have a pull request opened by renovate bot, and if I see all the green check marks, all the combinations of end-to-end tests, visual tests, code coverage saying it hasn't changed, I actually feel confident enough for automated pull requests to be merged automatically. So it might not be.
This is how you move fast.
But that's how I move fast, right? I actually feel that with all the coverage that I know and all the tests that we've written that exercise this application from a variety perspective, right? From a point of view of a user, but these tests give me confidence to auto-merge this. I might not trust it to auto-merge a breaking change, like a major version upgrade. That I would review manually before I merge it, even with all the green tests. But in majority of cases, I actually trust my tests, to be that reliable, so it can be auto-merged. So
you're shifting the equation that the risk that you broke something and you weren't aware of it is a far, far lower risk than sitting still on known vulnerabilities that someone could be using to attack your website or your application or something like that.
I think that's a very, very good view of that risk. I definitely feel that I trust my tests enough and I trust them to be dependable and have good coverage in all aspects, right? So that I don't want to stay on a broken version. That's more risky, right? All versions that never been upgraded, where I don't have a process to upgrade or pathway to upgrade fast. I don't want to be there, right? I don't want to use all versions. So I think good tests give me confidence, and this confidence allows me to move fast, to implement features, to benefit from performance improvements, from bug fixes in the dependencies that I use, so that my software and the product that I release is always up to date, fully patched, and safe, and ready for anything that has to be upgraded later.
Cool. All right, so let's recap a little before we get to the audience questions. So, at the start, we talked about how most software companies found themselves involuntarily all remote, and whether this had exposed any shortcomings. If I could capture it, I'd say that tasks that are important need to have a process in place that is never skipped.
Yes.
The best way to ensure that you never skip a process and make sure a process happens is to automate it. The more asynchronous the team's communication, the more likely that bad process is exposed. And in particular, important tasks can be missed when people are not, with regular routines, shoulder to shoulder, and so on. So we talked about securing code that you write versus code someone else wrote. Gleb, you covered open source updating and patching. We talked about how to move fast with confidence, this slide. You need automated testing with a focus particularly on end-to-end testing, because it's no good if your software works in units, but ultimately doesn't work for the end user. And I'd be lying if I said I'd never shipped software that passed unit tests but broke something really, really badly. So I was glad to learn more about that. Okay, so I think we got Charlene back in, and we'll get to some of the audience questions.
Yes, we've gotten some great questions in, but there is plenty of time. If you have a question for Reese or for Gleb, please go ahead and use your GoToWebinar control panel and submit your questions. But let's go ahead and dive into what we have here right now. So here's number one for you. Shouldn't companies have good processes, though, no matter how they work? This is not exclusively for remote work, right?
Yeah, correct. So it's exactly correct. The idea we had was to work out like what weaknesses can be, exposed when things change, and good processes are not exclusive to remote teams by any means. But teams that even go back to like fully, face-to-face, shoulder-to-shoulder, still need to keep investing in process. It was more just that, lack of process is more easily exposed when teams are remote.
All right. Excuse me. Next question here. Which do you think is overall riskier to a company? Their own code or open source code they use?
Good.
It's a balance, right? And every dependency probably has its own risk, right? I would say if the software you depend on is very, very popular, used by hundreds of projects, is a collaborative work of many developers, right, in open source model, that's probably a lower risk than your own code. But you've written on a deadline, pushed quickly, maybe someone else written test, maybe not, right? So in that case, the open source project is low risk, I would say. If, on the other hand, you're using a dependency by someone who has written it 2 years ago, never updated since, right? And you are the only user of that software, that's probably that one is riskier.
Yeah, I'd say it's hard to get like a single answer to that. It depends upon the type of software you're writing, because if you're writing crypto or something, then the mistakes you made can be huge. Also, it depends upon who wrote the open source software. So Gleb used React as one of the examples. It's very popular. Frankly, I trust the engineers at Facebook to publish more secure code in React than probably nearly everything that I write on my own. So whereas, like Gleb said, software one person wrote 2 years ago and never updated, that's going to have a lot higher risk.
Sure. All right. Makes total sense. Okay, next question. I'd like to upgrade dependencies frequently. I just lost my question. Hold on. There we go. I'd like to upgrade dependencies frequently, but I've had them break on me sometimes. Isn't that a problem?
Yeah, I think that one maybe was asked partway through, because Gleb kind of answered that one. Gleb?
Yes. That's why like this whole talk, right, is that you have to understand why it broke, right, and write tests to catch the breaking. The breaking tests are actually a good thing. That means they're working, right?
All right, great. Still plenty of time, guys. If you have a question, go ahead and use the GoToWebinar control panel and submit it. Here's the next question. Is your trust in devs to make this decision based on history, or is there a benchmark we could use?
It's a good question, Gleb.
It's a good question, but it's hard to just give it a definite answer, right? I would trust you to do 100 small upgrades, one by one, and then handle a really important security upgrades, more than if you never upgraded anything and then a security upgrade happened and then you did it one time. I think practice, kind of builds expertise in upgrading.
Yeah, I do think, like the last section Gleb presented in the slides, that the more trust you have in your tests means the less trust you need to have in the individual abilities of developers or the past history of the developers. I mean, that type of approach of making sure nothing broke in the software you release to your users, that's the kind of thing that just pays itself off over and over, instead of relying on your developers to kind of get better at intuition or something like that with updates.
All right, then. Next question. Most of the Java VM apps are running on version 8.251 or below. How do we test two Java VM Oracle versus Azul Systems JVM on security on their runtime?
Yeah, okay. So yeah, a lot of the Java is running version 8. You see surveys have that pretty common. Gleb, how do you approach different versions of JVM in the browser, for example, with browser testing?
So honestly, we don't deal with Java running in the browser at all nowadays, right? Most of our world, I would say, moved on from applets and Flash and Silverlight to standard web APIs. So I would say try to upgrade, try to do a big step forward and use HTML at this point.
Okay.
All right, we are about 10 minutes to the top of the hour, so we have about 5 or 6 more minutes for the question and answer period. So there's plenty of time, guys. If you have a question, please go ahead and put it in. Here's our next question. Let's see, sometimes it seems like open source is too risky to use, but I also cannot write everything myself. So what is your opinion on that? And how do you decide when to write or when to reuse?
Okay. So, at White Source, open source vulnerabilities is one of the main things that we do. So, I think that having very good security awareness in open source is something that enables you to use open source rather than something that should like scare you away from it. The reality is that nobody can rewrite everything, for their applications, whether it's phone apps, whether it's backend apps, or whether it's websites. We do need to like all stand on the shoulders of giants. So I think that the fact that the industry has got better at servicing vulnerabilities, and we have these things like automated testing, we have vulnerability alerts, we have automated pull requests for vulnerabilities. I think all of these things make it better and better to use open source rather than like attempt to write it yourself. There's many different categories of vulnerabilities that require very high ability from a developer to avoid in the first place. Some of the buffer overruns and string sanitization and things like that. These days, it's pretty much nearly always better to take like a popular or semi-popular package from open source than attempt to rewrite that type of stuff yourself.
And if I can add to that, right? We kind of said, if there is a security vulnerability discovered in open source dependencies, then like every hacker knows about it. But think about the opposite. The open source has so many eyes on it and so many users that those security problems discovered, right, will probably discovered faster in open source implementations than your own hacky, kind of re-implementation of some kind of encryption algorithm, right? So you benefit from open source, I think, a lot more than you risk by using it.
Yeah, don't go writing your own crypto.
Yes.
You're right. All right, great. Our next question here, does open source have a problem with vulnerabilities that can get better, or is it something we just have to accept?
Okay, I answered that one sort of by accident just before. I think it's getting better. I think we're getting better at writing, and we're getting better at finding the problems. And it's a virtuous cycle.